Today we will discuss about organic reactions and types of organic reactions. Simply in organic reactions, we say reactants are converted into products. Now reactants molecules react to form product molecules. Reactant molecules are of two types. First is called substrate and second is called reagent. Now reagents are or attacking reagents, these are substances which are being attacked on substrate. So these are substances which go and attack. So substrate are substances which are being attacked by reagent. So reagents attack on the substrates to form either transition state or intermediates. Now in sometimes in concerted reactions, reactants react to form transition state which is unstable and ultimately converted into product. It is not isolated, or some other reactions reactants react to form intermediates like carbocation, carbanion, free radical, nitrene, carbene, etc. So then these either transition state or intermediates convert into product. Further, now we will talk about reagents, types of reagents. Generally reagents are of two types. One is called electrophiles or electrophilic reagents. Second is called nucleophiles or called nucleophilic reagents. Now electrophiles or electrophilic reagents are those substances or those ions or molecules, those species which are electron deficient. So electrophiles are electron deficient. So these are, for example, methyl ion, hydrogen ion, BF3, aluminium chloride. These are of two types. First neutral, that is BF3, aluminium chloride, etc. or positively charged like methyl ion, then H positive, hydrogen ion, hydronium ion, etc. Now second class is nucleophilic reagents or nucleophiles. Now nucleophiles, these, as name suggests, these are nucleus loving, electron rich. So nucleophiles are nucleus loving or electron rich species. Nucleus loving, as we know, in nucleus there is positive charge. So positive charge, so it means these substances have a friction for positive charge. So these are further of two types. One is negatively charged like amide ion, cyanide ion, etc. Second is neutral like ammonia, water and alcohol. Now in case of neutral nucleophiles or nucleophilic reagents, these are those substances in which one of the central atom contains lone pair of electrons. Next we will discuss types of organic reactions. So next is types of organic reactions. First is substitution reactions. Substitution reactions are those reactions in which an atom or group of atoms are displaced by some other atom or group of atoms without any change in remaining structure of molecules. Supposingly we take example of chloroethane. Now in this case, aqueous KOH attacks on this chloroethane. So here this chloroethane is substrate and aqueous KOH is attacking reagent. Now in this attacking reagent KOH में से now OH जो है, that is hydroxide ions, attacks on this CH2 molecule. So results in the formation of ethanol and KCl as side product. So another example of this, that is, let's say this is bromomethane. If it reacts with potassium cyanide, then it forms CH3CN. This is cyanomethane plus formation of side product, that is KBr. So second type of reactions are addition reactions. Now addition reactions are those reactions in which two or more molecules combine to form a single product. That single product is called addition product. For example, CH2 double bond CH2, ethene, plus bromine, Br2. Here CH2 double bond CH2, this is ethene is the substrate and CH2 Br2 is the attacking reagent. This forms 1,2-dibromo. This is 1,2-dibromoethane. Another example of this addition reactions are CH2 double bond CH2 plus HCl in presence of catalytic amount of H positive. It forms Ci3CH2Cl, that is chloroethane. So in these reactions, two reactants combine to form a single molecule, that is called addition product. 1,2-dibromoethane in first reaction and 1-chloroethane in second reaction. So third type of reaction is elimination reactions. So normally in addition reactions, one of the reactant must be either double bond or triple bond molecule. So carbon-carbon bond must contain either double bond or triple bond. Next, third one is elimination reactions. Now in elimination reactions, these are those reactions in which a either number of atoms, group of atoms, or a simple molecule basically removes from a reactant molecule to form a either double bond or single bond product. Like let's say we have Ci3CH2Cl, this is chloroethane. If it reacts with KOH, alcoholic, so attacking reagent is alcoholic KOH. If chloroethane reacts with alcoholic KOH, it forms CH2 double bond CH2. This is ethene. So there is formation of ethene, carbon-carbon double bond, plus side products, that is KCl and water. So in these reactions, elimination reactions, normally there is formation of double bond or triple bond, or we can say that elimination reactions are reverse of the addition reactions. So another example of elimination reactions, let's say if we have, so this is tertiary butyl chloride. When tertiary butyl chloride is treated with alcoholic KOH, then the product formed is, this is 1, 2, 3. So this is 2-methyl propene plus KCl and water as side products. Next, fourth type of reaction is rearrangement reactions. So rearrangement reactions. So these are those reactions in which one of the atom from the carbon chain is migrated from one place to another place. Like, let's say if we have example of this is bromopropane. In presence of aluminium bromide as catalyst at high temperature, nearly at 575 Kelvin. So the product formed is 2-bromopropane. So here in this reaction, bromine, this group migrates from one position and attaches to second position. So we get 2-bromopropane. So these are rearrangement reactions. Sometimes in rearrangements, normally there is whole rearrangement of the molecule, or we can say there is change in skeleton of carbon atom. Let's say if we have N-butane, this is N-butane. If N-butane is treated with HCl in presence of aluminium chloride as catalyst at heating conditions above 500, then it results in the formation of, so this is 1, 2, 3, this is 2-methyl propane. So here carbon skeleton is changed. Here there are 4 carbon atoms in a straight chain. Here there are 3 carbon atoms. So next type of reaction is, fifth one is isomerization reaction. So fifth type of reaction is isomerization reaction. So isomerization reactions are those reactions in which one isomer is converted into second isomer, another isomer, without affecting remaining structure of the molecule. Let's say we have example of geometrical isomerism, that is trans 2-butene. So this is the transform. When we heat this product, or generally we in presence of UV light or sunlight, it is converted into cis product, that is cis isomer. So this is cis 2-butene. So here only one isomer is converted into another isomer, remaining structure of the molecule is not affected. So last type of reaction is condensation reactions. So condensation reactions are those reactions in which either two molecules of same type or two molecules of different types condense to form the condensed product, or with the formation of some simple molecules like water, ammonia, etc. Let's say we take example of acetaldehyde. In presence of alkaline sodium hydroxide. So here this is the example of Aldol condensation reaction. Here two acetaldehyde molecules react to form this is 3-hydroxy butanol. So this is Aldol product 3-hydroxy butanol. In another example in which two different molecules condense, let us suppose take example of crossed Aldol condensation. Let's say we have one of the molecule benzaldehyde So when benzaldehyde is treated with acetaldehyde in presence of alkaline hydroxide ions, so sodium hydroxide or potassium hydroxide, it results in the formation of crossed aldol product. Now in presence of either H positive or OH negative, this aldol product is crossed aldol product is converted into this sphingmaldehyde with the elimination of simple water molecule. So these are the different types of aldol organic reactions.